Okay, hello everybody. That's very echoey. My name is Martin Woolley. I work for RIM's developer relations team. I'm based in the UK. I am British and therefore have a bit of a strange accent. But no matter, because I'm joined on stage today by my learned colleague and friend, Rob Williams. He's also from developer relations, but he's based in Toronto, Canada. Now, don't assume he's a Canadian, because he's not. He's actually from the land down under, known as Australia, and therefore also speaks with a funny accent.
I don't have an accent. I don't have one.
So if you were looking for a session with two guys who speak a bit funny, you found the right place. Thanks very much for coming. Really pleased to see you all here anyway. I hope you enjoy this session. We've thought kind of long and hard about the topics to cover today. And we'll show you the agenda in a moment, but basically the thought process went along these lines. If you read about NFC in the media, you probably are reading about payment. Probably. It's the topic that NFC has become most closely related to, I think, in the media. But what we hope to convey today is that there's a lot more potential to the technology in using it in all manner of different types of application. And the goal here really is to talk about particular aspects of NFC with which you can spice up your apps, make them a little more compelling, interesting for users through your creativity plus our technology. So, I'm going to do an introduction in a moment, and I'll come back to that. The main parts of our session focus on two particular aspects of NFC that we think have the most potential. Anybody can use them. They can be used in all manner of types of application and use case. Rob's going to talk about NFC tags, how we can use them to trigger actions. I'm going to talk about NFC's peer-to-peer mode, which involves two devices coming together and doing something. In each case, we're going to have a bit of theory, so there'll be some terminology and an introduction to what this aspect of NFC is all about, for those people for whom it may be new. There's going to be a demo in each case, so we're going to do a live demo of some kind of proof of concepts applications to illustrate some of the ideas. And then we'll dig down into the code behind the demos and find out what we had to do to implement the NFC aspects of those applications. Well, hopefully you'll leave kind of knowing that it's actually quite easy and with some great ideas of your own for your own applications. Regarding the introduction, the assumption, which I'm going to check in a second, is that we probably have a mixed audience in the sense that for some of you it's a relatively new topic, whereas for others, in contrast, you've been working with the technology for some time, you've developed perhaps with the BlackBerry 7 APIs, worked on other platforms, and so on. So we probably have different people to accommodate here. So I'll start with some opening statements about some of the basics, then I'll hand over to Rob. So that's the plan. And all done with a funny accent, as I said. I'd like to just find out a bit more about who you all are before we move on. I'm not going to ask for life histories or star signs or any of those things. But if, by raising your hand, you could indicate that you've already developed NFC software of some sort with the BlackBerry 7 Java APIs, please, that would be useful. So who's done something with our Java APIs?
Looks like 5.
I think that's 5 as well. Confirmed. That's why he's here. Okay, to do the counting, I'm kidding. Okay, thank you. Has anybody experimented yet or done something more serious with the BlackBerry 10 native APIs for NFC? We have 2 winners. There is no prize, by the way, but thank you. And has anybody similarly worked with other platforms, non-BlackBerry platforms, to develop NFC software? We have a few. Non-BlackBerry, other platforms. Okay. That's all right. We forgive you and we still love you, as long as you develop for BlackBerry as well. It's fine. Other stuff you do in your spare time, that's okay. So I'm going to move on now and cover some of the basics for people for whom this is a relatively new subject. And open by making a kind of strange statement, I suppose, to the effect that NFC, near-field communications, is a magical technology. Now, I understand that it's not, that it's actually science and some fairly hardcore engineering, but I've been conducting what I'll call experiments with friends and family to see what effect NFC has on them in terms of user experience. And I was talking to Rob about this and explained I've been doing these experiments, and he did look quite alarmed. I think he had the idea that I had some kind of laboratory in a dungeon in my house, and I haven't. It wasn't anything sinister. So all I've been doing really is handing, BlackBerry, NFC-enabled BlackBerries to friends and family that don't already have them, and telling them to do things. Touch the special poster on the wall, or touch your device to my device because something will happen. My goal was simply just to watch their faces and see what happened there, and it was interesting. I think in all cases, initially, I got a sense that there was a deep distrust of my motives and what was going to happen, which may say more about me or my friends and family. I'm not really sure which, but yeah, that wasn't too good, really. But eventually, I calmed them down, persuaded them to do as I had asked, and they touched the poster or they touched the devices together. And then it got interesting. They looked surprised, looking at the screen. Then they looked delighted, and then they looked away from the screen to me and smiled every single time. And that's why we're talking about NFC and the aspects we've chosen today, because it can have that impact. So the opportunity for you is to find creative ways to incorporate NFC, for reasons I'll come on to, into your applications, whatever sort they might be, because people love it, okay? They really like it. The kinds of things you can do possibly fall under 4 headings, depending on how you look at it. These are my headings. You can certainly use NFC to trigger actions. So you touch the device to something like a special poster, and it makes something happen. And this is what Rob's going to talk to you about when we get to his part of the session. The middle 2 are similar. They fall under the peer-to-peer heading that I'm going to discuss. But you can certainly use NFC to transfer state between 2 instances of an application running on 2 devices. And this is cool for things like games, probably other things too. But passing state information about the state of the board that you're playing on or something like this from device A to device B just by touching is a really nice thing to do. And I'll explain why it's nice in a second. You can also transfer what I would call larger grained objects between devices. These are things like photographs, music files, contacts from your address book, and so on. And again, just by touching. This just by touching phrase I'm going to keep repeating, but this is the essence of why NFC is a great thing that people really like. Finally, you can execute what we'll call transactions for the purposes of today's session. If you know all about NFC already, I'm talking about card emulation. It's a more complicated area, but NFC is more than just a radio technology. From one point of view, it's a very short-range radio technology with a range of 2 to 4 centimeters, depending on lots of variables. But it actually comes as part of a bigger architecture, which includes something called a secure element, which is a place to run security-sensitive code. It's like a smart card environment, and other things beyond that kind of system boundary as well. But it makes it very good for things like payments. That's why NFC and payments have come together, because it has an architecture that accommodates the idea of emulating things like credit cards, which in Europe are smart cards, in a secure way. And payments not the only use case there. Things like physical access as well. So use your smartphone in place of your ID card to be able to enter a building. Touch your smartphone to the door entry system. Touch your smartphone to a point of sale reader to pay for goods and services. Touch your smartphone to a barrier system to enter the train system and get on the train. These are the kinds of things you can do with this transactional card emulation capability of NFC. It's quite specialized. There are business issues that make it hard to deliver those kinds of solutions, as well as technology and kind of skills challenges. The other stuff, though, is very, very easy, and anyone can do it and use it for all manner of things. So the opportunity, or I guess in a sense the benefits that you will accrue through implementing some form of NFC capabilities in your applications, whatever they are, is that you turn a good application into something that has some other characteristics. It becomes tactile, because NFC is all about physically touching. And we don't do this much anymore. Social has become, it means something different now, social. It's about interacting in a social-like way with remote people who we may never meet. NFC is the opposite. It's about proximity, closeness, and physically touching. You can make workflow processes utterly frictionless. If to move to the next stage in the workflow, you just have to touch something. Access to information, really convenient and easy. And you can make games even more fun if you're playing face-to-face against someone. We have a secure bar across the bottom there. This is to indicate that if you do have security requirements, that architecture of NFC that includes the secure element component gives you the opportunity to create truly secure solutions as well. There's a lot to the subject. It's very interesting in my opinion. The bar at the bottom there gives a quote from an analyst, and essentially there are going to be an enormous number of mobile users who have NFC in their pockets. You know, the prediction there is that by 2015 there will be 250 million devices. It's a really, really large number. It's going to be utterly pervasive. It's growing like crazy in Europe, where I do most of my work as well. I'm working with lots of carriers who are rolling out all sorts of NFC-oriented solutions. And I know for a fact big credit card companies like Visa as well are rolling out things like contactless point-of-sale readers across the UK. So lots of investment going into it. It's coming. So one of the questions I'd be asking if I was you was, well, how hard is this and how much effort will it take? How long will it take? You know, this sounds good, but will it double the amount of development time required? And the answer is absolutely not. I've got a slide here which doesn't quantify anything. It suggests that triggering actions using NFC tags, Rob's topic, and the peer-to-peer capabilities that I'm going to talk about requires small effort. But what does that mean? It means less than an hour, definitely. It's minutes of coding to add these kinds of capabilities to the remainder of your application, no question. And we provide you with loads of sample code and written description of how to approach these topics that should make it really easy for you, we hope. If not, you can tell me. The transactional stuff, no question, harder. Some specialist skills are required somewhere in the team. You need someone who knows about smart card development, for example. You probably need domain-specific expertise, things like payments, standards. I've said medium, it might be large. I don't know, the devil's in the detail for that one. The other stuff, though, really easy, and the benefits are great because, again, users love it. Okay, I'm going to hand over to Rob now. He's going to talk to you about NFC tags.
Okay, thanks, Martin. So firstly, what are NFC tags? Well, they are memory cards that store data. Now, here's something interesting to actually look at. I have one here that's on sticky paper, so very flexible. Now, if I shine a light under that, we can look at it. So I just have to activate my light. Now, hopefully everyone can see there a coil and some denser bits. So the two denser bits here, that is where the IC is connecting into that antenna, and the denser bit on the other side is a loop bypassing the antenna, so we can reach both sides of it. Now, this is also pretty cool. Those chips get all of their power from the field when you're talking about a pure and simple tag. Martin brought this with him. It's an NFC field detector. So again, there's a coil, and then only 2 contact points going into one tiny white chip. My BlackBerry 7 device's NFC field is on, so hopefully making the light glow. I think that's pretty cool. So when you're carrying this around, it is emitting, when NFC is turned on, a 13-point-something megahertz field, waiting for a chip to come in range, which could be dormant for years before it comes into range, or for an active device to come into range. Pretty cool stuff. They have a contactless interface. So you can come up to these cards, come up to these chips, hover or touch, and you can read their content. You'll note in the picture here a contact full card. And yeah, you can be sending messages via the contacts if you want. For some Visa cards, as you mentioned, that's what happens. You could be putting them past an NFC reader, or you could be putting them in a contact full reader. The same secure element is going to be exchanging the data. They are read by a device. In general, it's going to be termed the reader. And then you have applications that respond to what they just read. So a little about some of the types of tags that there are. So, can we switch back to the slides, please? So there are 4 standard NFC forum tag types. They have a message format, which is called NDEF, which is the NFC data exchange format. There are a bunch of standard messages, which are coded into tags. I'm going to mention Smart Poster in a second. Text and URI, really obvious. So on the card, little tiny bit of header, followed by some text. URI, header, followed by some text, which is the URI. You can have image ones as well. So it's a header, a MIME type, some binary data. Smart posters take all of those together and put them into one bundle. Oh, we have someone in the audience waving a smart poster at us. Good stuff. So inside a smart poster, you can have text in multiple languages, a URI, an image, all bundled into one. So the fun thing about a smart poster tag is you take your device up to the tag, scan it, you can see an image, you can see a URL in the appropriate, and a text description in the appropriate language, which is all pretty neat just to walk up. QR codes can achieve similar behaviors, but this is going to be faster. You walk up, you hover, not you stand there waiting for the camera to focus and you eventually scan the QR code. There are custom types. I mentioned text, images, URIs. You can put any media type you want onto your tag. Raise your hand if you're here and you're a BlackBerry Elite. Okay, there's a couple in the room. Did you guys actually investigate what's on that tag you were given? Well, it's a custom type. And custom types are useful if you want to make sure no one else is going to accidentally be reading your content. So if you have a URI on your tag, it makes sense to label it as a URI. That way, any device that comes up to it that is capable of recognizing a URI can act upon it. If you don't want that much flexibility and you have something specific, use a custom type. A really big problem is some of the capacities. There are some super small tags. This little flexible one I held up before holds something like 34?
64.
64
bytes.
64 bytes.
Bytes, yeah.
That includes partitioning information before you get the header information. So it has to choose which sectors are holding data. So 64 bytes, including the file system, which is not an impressive amount of storage. There are others that are up to 4K. So you can put a good size thumbnail image on the larger ones. So one thing that was in Martin's slides was acting on something. Raise your hand if you've done a fun run. Okay, we've got a couple of fun run guys. Did you, when you signed in, get a tag to put on your chest or on your shoe? Yeah. Okay, good stuff. Those are RFID. They're RFID, NFC, very closely related. RFID specifies more frequencies, different ranges, but they're essentially the same technology. Now, I'm not trying to say that you should build a finish line for a fun run out of BlackBerries or clip a BlackBerry onto your shoe as you're running across the finish line. Don't do that. What I am saying is here's a really simple sample of how you can respond to events. If we can switch over to the Elmo, because we won't need to play the video. Here we have one tag, which is labeled start, and another, which is labeled stop. So taking the fun run example along, as you punch in at work or you start the fun run, as you hover, as you start the run, you go past one tag. And this application has been written to respond to that content. Start your timer. So yeah, this is a very simple example, but this could be anything. This could be start playing your favorite song. Whenever you get into your car, you love to hear that song. Anything. And we have the partner tag. Oh, press the volume button to do the stop. So you can write anything onto these tags and make your applications respond in any way you want. A cool thing about the NDEF messages is you can have multiple NDEF messages on a single tag. So you could have a smart poster followed by a custom type. You could have a custom type followed by a smart poster. And depending on the platform, it might behave differently. If it can't understand the custom type, it does understand the smart poster. So you could go into some default operating system app and display the content of that smart poster. So in the fun run, we would start the timer, we would run, we'd start the timer, and then have a nice cup of tea?
Absolutely. In Britain, that's what we do. Definitely.
Okay, in Australia, we would go and have a beer to replace those calories. So can we go back to the projector, please? Thank you. So there's a 3-step process involved here. The first step is admitting that you have a problem. And you are drinking too... Oh, different steps. Okay, the first step is registering. Registering is all declarative for reading smart tags, for reading, NFC tags. In the bar descriptor, you specify what you want to be able to read. The bar descriptor is where a lot of stuff happens inside your BlackBerry 10 app. In there, you will ask for permissions to access the GPS. You will specify your splash screen. You'll specify your icon. You will specify which platforms you support. You will also specify your invocation targets. And you connect the invocation manager, the invoke manager, using Qt signals and slots, makes something happen. We're going to get into these in detail in a second. The third thing you do is you process that data that just came in. So this is how easy it is to register for an NDEF tag inside the bar descriptor. Now, if we jump down to the MIME type, we can see that his application VND RIM NFC NDEF. That is totally made up. So that doesn't have to be registered with anyone. You want to hope it's unique if you're going to write something special and only meaningful to your application. And that's the type that when Martin and John implemented the stopwatch timer, that they wrote onto their tags. Now the property there, the property var URI's value, NDEF, that's a URI specific for BlackBerry 10, saying that the type of thing we are going to be invoked about is an NDEF event. And it's type 4. What's 4? I said there are a couple of NDEF types of messages and NDEF well-known types. The well-known type for 4 is external. Type number 2 is well-known. Type number 3 is MIME. But NFC stuff, these are open standards. I may have just misremembered them, but you can look them up. 2 is well-known. I'm pretty sure of that. 4 is external. If your stuff's not working, you should check the standard. And up the top, the invoke target ID. I have to stress how important it is that this is unique-ish. When you actually sign your application, we at RIM remember which invoke target IDs you have used before. No one else will ever be able to sign an app that uses that invoke target ID. So if you've switched keys or someone else on your team is trying to sign your app and nothing's running, it's because you're not allowed to have that ID shared between keys. Now, the invocation framework, who is familiar with it? Who's heard of it before? Quick show of hands. I would say a quarter to a third of the room said yes. It is the way that inter-process events happen on BlackBerry 10. So when you press the share button as you're viewing an image, all of the applications that have registered an interest in sharing images are candidates. So because you have registered in those URLs, so URIs, that you are interested in receiving those NDEF events, you will be invoked eventually. So here's what happens. The tag comes into proximity. Your app does not know this happens. The NFC stack inside BlackBerry 10 reads the content of the tag. Again, your app does not know this is happening. Then the invocation framework looks for something that will respond to this type of tag. If you had registered an interest in text or URIs, there's a good chance you're not going to be the only app on the platform. So if your app wasn't running, and neither were anyone else's that were registered, BlackBerry 10 would open up a chooser saying, what should I do with this tag? Because here are the 5 apps that have registered interest in URI tags. For the case we had, only one app is interested in this stopwatch timer game events. Then your app, if it's not already open, is started. If it was already open, it'll just receive an event, and it comes in. When you receive an invocation event, you get the actual data that was transmitted. So, here is how you connect to the invocation framework. So, we create an invoke manager, and we ask that when it is invoked, that we call my received invoke request. Not much to that. When you process, you get an invoke request. You can get the data out of that request, and then the Qt mobility subset, it has classes to decode that already. Then, once you have built that data, you can look through for NDEF records. So I'd mentioned that there can be multiple records in a message, so it's always good to iterate through because it might be the 4th one that is the one you're interested in. Look for the right type name format. In our case, we were looking for 4, which here is defined as a C++ constant, which is part of the QNDEF record class. If the content type is what we expect, we're going to emit the Qt event, fire the Qt signal is more correct to say. A race tag was detected. That's all there is to it. So inside the handling for race tag detected, you would look if it was your start tag or your end tag. But previously, when Martin said it is a low-level amount of work to read tags, he was being serious. Back over to you, Martin.
Fantastic. Thank you, Rob. Okay, so we've hopefully seen how easy it is to code applications which respond to NFC tags. That's one use case. Make something happen just by touching. I'm going to talk now about NFC's peer-to-peer mode. If you read the technical specs and so on, there are a number of formally defined modes of operation. Peer-to-peer mode is one of them. And this, of course, involves 2 devices coming together to have a kind of conversation or exchange of data. Not data, by the way. Data, I'm sorry.
We have a show of hands.
Yeah, I should be careful. So to revisit this idea of the opportunity, why should I bother doing this? The essence of what can be achieved with NFC's peer-to-peer mode is that you can create what I would call physically interactive experiences. This physical thing, again, about it being tactile. It's a really important aspect of what NFC is about. NFC is about convenience on one hand and ease of use. You just touch and something happens. But physically interactive as well is a kind of new thing in a way. We've been interacting with quite abstract remote things through our applications and services for some time. Now it's time to get physical. Okay. Talk a little bit now about the technicalities of NFC's peer-to-peer mode. NFC is obviously a kind of large protocol stack. It's got lots of different layers to it and constituent parts. Where peer-to-peer is concerned, we're primarily interested in 2 upper layers called SNEP. That's the Simple NDEF Exchange Protocol, so you know what NDEF is from Rob's talk earlier on. And SNEP runs on top of a lower level protocol called LLCP, the Logical Link Control Protocol. Now, from your viewpoint as a developer, SNEP appears as a message-oriented protocol, And the API is quite high level, and I'm going to show you what this looks like shortly. It's really, really easy and fast to use. LLCP, which it runs over the top of, is lower level, and it's a kind of connection-oriented interface that you have, which is very, very similar to working with TCP/IP raw socket connections. You know, you open connections, you read and write, you flush, you close. Those kinds of things are going on. It's quite good for exchanges of multiple messages by way of a kind of conversation when two devices are brought together. Handshakes, those kinds of things would be good to implement using LLCP. My preference is that, well, my approach basically is that unless I have a really good reason to use LLCP, I will always use SNEP, simply because it's so much easier. It's very fast. I can get things done really quickly using that API, and it will generally meet my needs. I'll have a special reason if I want to use LLCP beneath that. We also have some options in terms of general approach to coding peer-to-peer interactions. We can either leverage the invocation framework again, I'll explain what I mean by that in a moment, or we can make direct use of the APIs that we provide. And I'll kind of compare and contrast the two now. Invocation framework has a number of roles. It's a really, really powerful part of the BlackBerry 10 architecture. And one of the things it can do for you is locate other applications on the device which are able to provide services that your application can exploit. So if, for example, my goal is to send or share a message with another device over NFC, then maybe there's an application on the device that already has that capability and has exposed it to the invocation framework by registering and saying, hey, I'm able to handle this type of data and perform these types of action on it. You saw hints of what that looks like in Rob's talk, where you saw how we would register for receipt of NDEF messages from the invocation framework. So kind of switching the concept on its head here. Now, the benefit of using the invocation framework in this way is that I probably have to do a little bit less coding because I'm exploiting some component of another application that's advertising its ability to do this for me. What you may find is an issue to consider is that the invocation framework may inject some of its own personality into your user interface and the user experience. There may be occasions, for example, where there's more than one application that's capable of providing that service, in which case the user will see slide-out menus and have to choose the one they want and so on. And that might be absolutely fine for you. Perfectly happy with that user experience, want the benefit of getting this done the easy and fast way. The alternative, if you want complete control, is to make use of the APIs, which is still, as I hope you'll see in a moment, really very easy, not an awful lot of coding required. You'll basically be, there are a number of ways you can code this. I'll explain one of them and then kind of contrast with some alternatives towards the end. But essentially, you'll be working with events from the BlackBerry Platform Services, part of the BlackBerry 10 architecture. You'll be receiving events relating to NFC activity, and you'll respond to them in some appropriate way. So you'll take responsibility for coding all the NFC stuff, which as a sentence makes it sound like, oh, that's big and scary. It's actually not. It's a very small amount of coding required. But you'll have complete control over what happens and what the user actually sees. So we'll look at the invocation framework approach briefly first, and then I'll show you the other way, the direct API approach. There are other sessions on invocation framework. You may already have been to one. I'm not sure what the scheduling is, but definitely I'd recommend going to one of those if you get the chance. So on screen now, I've got some QML. So this is part of the declaration of a button. And in that button declaration, I've got something called an invoke action item. I've given it an ID, which I'm going to refer to elsewhere in this declaration on the next slide. But the key part I'd like to draw your attention to is the query. Here I'm saying, I'd like an application that can handle this MIME type to do something for me. I'd like it to be able to share, that's the action name, data of this type, and you can see it's NFC NDEF data. One thing I should explain is that when I send data over a SNEP peer-to-peer connection, it's going to be in the NDEF format. So it's just like sending a tag from your device to the other rather than it coming from one of the flexible card type tags that you saw earlier on. And what I do here in the remainder of my buttons declaration, I use the onShowing event that basically means once my button is showing in my UI, I use that as an opportunity to make a call, in this case, into one of my C++ methods, where I create an endef message, and we'll see what's involved in that kind of thing shortly. And having done so, I assign the result, which is a byte array, to my invoke action item. So now it's got the data, and it knows what I want to do with it from my query definition. And the net of all that is, when the devices come together, the data that I've just created will get sent across. So that's one way of doing it. The other way of doing it is with the direct APIs. And we're going to try and do a demo up here now, before your very eyes, of something I've decided to call proximity gaming. It's not an industry standard term, but it's the idea of games where the users are right next to each other. It's the kids sat in the back of the car or whatever, but they're face-to-face and they're playing a game, a two-player game, a multiplayer game, something like this. But you can look into the opponent's eye and play this game using NFC to drive the game action forwards. So the game we're going to play is, I believe, known in these parts as tic-tac-toe. Where I come from, we call it noughts and crosses, but it is the same thing, I think. And I need a volunteer for this game. Rob.
I will volunteer. Martin,
Excellent.
I was thinking perhaps we should make this a little bit more interesting.
With this, what is that?
It's $5 Canadian.
Well, if that's all you can offer, then I guess I'll have to accept, but fair enough. What am I going to do with that? But thank you. He's obviously very confident. Okay, perhaps I should smell a rat. There's probably some experience here, some tic-tac-toe expertise that I don't know about. But yeah, so we're going to play this game, and then we'll reflect on what we saw, and then I'll show you the code. That's the cunning plan. So, do you want to... First thing we're going to do is decide who is player one. It's difficult to demonstrate with the Elmo, but let's see what happens here. Okay, hopefully you can see, and you heard the beep, that I have been selected as player one, which means I have control of the board, and I'm able to make my move. I move the other player's device out of the way. So I'm very cleverly going to start in the top left-hand corner there. I have a plan, by the way. Okay? And now I'm going to hand control of the board over to Rob, who will take control by touching devices. And there he sees the move that I made. And it's now his turn. He has control of the board.
So I've gone in the bottom right corner.
Which I, of course, do not know yet. Oh, interesting. He's a deeper thinker than I realized. Okay. Do your worst, Rob.
I'm going to try a tactic that doesn't always work here.
Okay, I heard the chuckling. I'm bewildered because I really don't know what you're laughing at. Oh, hang on, I see my opportunity.
God.
Swooping in for victory. The $5 Canadian are mine. I never win anything. So I'm very happy about that. Thank you, Rob.
Yeah, you're welcome.
You're a valiant loser. There you go, you can have that. Oh, you're too kind. You're easily pleased, thank you. Okay, so let's reflect on what we just saw. Proof of concept. Again, the idea here is to talk about all the other things you can do with NFC other than payments, which we read about all the time. So there we saw a game with two use cases where NFC was used. We had start a new game, and we had pass turn to other player. To implement the game, I used SNEP as my means of transferring data between devices, but for my specific game and its requirements, I had to invent a simple protocol, just some message types to indicate the kind of exchanges that I wanted to. So for start a new game, in fact, both devices sent a message from one to the other, and they crossed over. And those messages contained a random number, basically. So each device generated a random number, exchanged with the other device. They're now in possession of both numbers, their own and the other player's random number. Whichever was higher became player one. Obviously, a key advantage in a deeply strategic game like tic-tac-toe. I want Rob doesn't know, but when you see the code, you'll see there's a very high hard-coded number in the dev alpha version. Don't tell him, though, whatever you do. He'll be very upset. He's a sore loser. But that's what's happening there. Exchange of two messages, random number, compare them. Your player one, you go first. Pass turn, really simple. We just send a message from one device, the one that's in control of the board, to the other with the numeric ID of the cell that's just been changed. Simple. So all we had to do is touch devices, and basically game state is being transferred across the NFC contactless interface. What it doesn't say on the slide there, under more natural circumstances, it's a lot of fun. It really is, because you're just touching, you're doing this, and you're touching backwards and forwards, and it's just fun, and people kind of laugh when they're playing it, because it's also unusual at this stage. The other thing I want to draw your attention to is this. You just witnessed some interesting interoperability, because we were playing with a BlackBerry 7 device on the one hand, which has a version of the game implemented in Java against a dev alpha Series A, as it happens, running a version of the game written in C++, Cascades. Okay? And they work seamlessly together because NFC is a highly standardized technology. There's an organization called the NFC Forum, and they look after all the, checking the time here, all the standards for NFC. And so as long as vendors like us comply with those standards, which we work really hard to do at RIM, we think it's really important that you comply with the standards, because interoperability is all. Think of those 250 million devices. Okay? If they've not all quite implemented according to the standard, it's not really going to work as seamlessly as we should want it to for end users. It's got to just work when they touch. That's the goal. So that's why standards matter, and you just saw a great example of interoperability that could be achieved as a consequence of those standards and our determination to adhere to them. So once again, we have a three-step process for coding this stuff. In this case, the three steps are register, detect, and respond. Register is really simple. I'll show you the code in a second. You've kind of seen it already, to be honest. One API call. Detect you can do in a number of different ways. I'm going to show you one way of doing this, and I'll reflect on some alternatives at the end. And respond is kind of what you then do to push your message across to the other device. Detect means another device has come into proximity with your device, and that's your cue to make your message and send it across, which is the respond step, to make sure I made that clear. So let's look at some of the code then behind those three steps. The register step is a single API call. NFC, register, SNEP client. And what this does is it puts our device into the right NFC state, such that when another device comes into proximity, we can progress through those next steps in the process. The detect step you can do in a number of different ways. The APIs have been progressing since we released Beta 1 back in May or whenever it was, Beta 2 a little bit later, and Beta 3 round about now, right? So there are now alternatives that we didn't have back in May. It's really quite interesting. You can kind of choose whichever is your preferred style of programming. And what I've got here is a procedural approach. BlackBerry 10 has something called the BlackBerry Platform Services. It's able to deliver events of certain types to your application. There's a system of event domains, or event types, if you like, and you can say, hey, BlackBerry Platform Services, I'm interested in events of the following types, and it will deliver them to you. You just kind of request them from the BPS system. And having received an event of a given type, you then process it according to your own required logic. So what I'm doing here is I'm calling them in a while loop, and I'm calling BPS get event, and I'm receiving, after a potential wait, an event object. I can establish what domain, what type, what broad set of events it belongs to, event types. If it's an NFC event, I'm then going to handle it, because I'm interested in NFC events in this application. Lots of other types of events, all sorts of sensors on the device, for example, all manner of things you can do with this approach. So in my handle NFC event method, you can see I'm passing in an object of type BPS event, which is a kind of high-level wrapper for all possible event types from the BlackBerry Platform Services library. I can find out what type, specific type of event it is by requesting the event code. Okay? And then we have constants which I can use to implement conditional logic. In the case of using SNEP, I'm interested in 3 event types only. The primary one is NFC SNP connection event, and this means, hey, another device just entered the NFC field. So this is my cue now to react and do the respond step, send it some data. The other 2 event types concern the success or failure of that processing. So first step, I get the event that says, hey, there's another device. I try and send it some data, and it will succeed or it will fail. Maybe the user could pull the devices apart really quickly. The data doesn't make it across. So I'm also looking for NFC NDEF push succeed event, and I'm saying this to you, by the way, because I find the next one a real challenge, and I thought it'd be fun, or NFC NDEF push failure IO error event. Yay, did it, which means it didn't work, okay? So a really simple conditional logic there. And if we get the first of these, the NFC SNP connection event, again, we're going to send our data, so I've implemented this in a method called send turn data. And it looks like this. So again, I'm passing on the BPS event object. Now, inside that BPS event object, like a high-level wrapper for events of various types, I can acquire an NFC event object. So I just call NFC get NFC event, very simple API call. NFC event objects are special because they relate, of course, to NFC. And one of the things they have inside them is something called a target object. Now, you can think of a target as being a kind of reference to the other device. Once I've got that target object, I can then initiate operations that relate to that other device, such as send some data to it. So a couple of APIs calls there to unpack the NFC event from the BlackBerry Platform Services outer kind of wrapper event, and then I grab the target object, and then I'm good to start sending data. The data I'm going to send I have to make, and once again, the data must be in the NDEF format. That's the rule for using SNP. Now, you already heard from Rob that NDEF messages have a kind of hierarchical or containment structure. You have a message which contains one or more records. And records, you give them a type and you populate them with data which is in the form of a byte array typically. So you can see here that I start off, I've got a Q byte array. I'm using one of the Qt APIs there, nice and easy to work with. I call an API call to create an NDEF record, and I say what type. So Rob mentioned the different types that are defined by the NFC forum. TNF external, TNF is type name format, one of the terms from the specifications. External means this is a type I'm inventing, it's a custom type, as opposed to one that I'd just like the other device to hopefully be able to handle. A URI is likely to have a handler already on some other device, but I don't want any application to handle my game messages, just mine, so I've invented my own type. I then create a message, so I've got a record with a type and a payload. I've got a message, and I add the record to the message object, okay? So messages contain records. I can add as many as I like, subject to capacity restrictions. And once I've done that, my data's ready and in the right format, and I just call NFC push NDEF message, specifying the target. That's my remote, my kind of reference to the other device, and the NDEF message object that I've just created and populated, and that's it. The data will transition across the contactless interface from device A to device B. Device B will experience exactly the same emotions, that's the wrong word, circumstances as when it reads an NFC tag. It's just getting an NDEF message, so fundamentally the same coding applies, nothing special on the receiver side. It may experience emotions, I don't know. So that's how to register, detect, and respond. I've talked about that for some time, but it's like 6 lines of code, really. There are other ways you can do the detect step now, though. Since we first released Beta 1, obviously we've been working hard on the APIs and making great progress there, and some newer options have arisen. Here's one. Basically, we want to make it easier for you, and we want to make sure that you can use your preferred style of programming. So in my detect step, I showed you an event loop, and that's a procedural programming approach, and there's nothing wrong with that, in my opinion. Some may prefer a more object-oriented pattern. Here's a useful class you may like to look at. It's called Abstract BPS Event Handler. To use it, you create a subclass, and basically it has a subscribe method that you can call to indicate event types that you're interested in, and it's your job to implement a method called event in your subclass, And essentially, after calling subscribe for each of the classes of events you're interested in, your job's done. You don't need an event loop. You will receive callbacks to your event method whenever events of the type you're interested in are kind of received by the device, processed by the BlackBerry platform services library. So no event loop. The event loop's dead easy, okay, nothing wrong with it, but you may prefer this approach. We're also doing work actually right up in QML as well. There's more things you can do there, so if you prefer to actually work at that layer, work with JavaScript and a markup language, we're making it easier and easier to do all sorts of things with NFC at that layer. There's a thing called the NFC Share Adapter as well, another very useful class I don't have time to talk about today. But over the next few weeks, the intention is we're going to publish more code in our GitHub repository that shows some of these alternative approaches, and write an article that talks about the fact that there are different ways you can approach some of these problems, and perhaps offer some opinion on how you might choose, although ultimately it's about personal preference. Okay, ready for time? Good. I'm going to hand back to Rob. He's going to make some well-chosen closing comments of some sorts. And then there should be plenty of time for questions. Thank you.
Okay, so we do have a bunch of resources that Martin just alluded to. And because this is an NFC session, we have those two URLs on these tags. So you can just come up and scan them with your NFC-capable device. Something that I think is fantastic about NFC is, well, Martin alluded to it being magical. You just have to be there. You don't have to get the Bluetooth pairing to work. NFC can be used to trigger Bluetooth pairing, but you don't have to do anything. You just have to be there. Your devices touch. Data can be exchanged. You don't need to download any other apps. It's there. Anyone here a fan of Stargate? Okay, so when you're looking at an Asgard computer station, do they stand way over here and like plug their cable in, or do they move the crystals around on the surface of the computer? The Asgard use NFC. Well, that's my theory anyway. So, yeah, have to mention that, of course. We have a roundtable session tonight at 6 p.m. in Exhibit Hall 1 if you wanted to talk to us about any more detail. Talk to us on Twitter, email us. And now I guess we had better open this floor for questions. Yep.
So who has a question?
Can the WebWorks access the NFC API through the NDK?
It depends on what you're trying to do. Did everyone hear the question? If you are trying to share to some degree, if you're trying to invoke, WebWorks is going to be fine because WebWorks invocation works. I do have a task to write a native extension for WebWorks to give it more functionality. So at this time, if you wanted to use Snap, I think you're out of luck.
Possibly.
Yes. Sorry, what was that comment?
I'm saying you can use native extensions.
Yes,
Yeah.
yes, you can use native extensions.
Thank you. Please join us. Yeah, I mean, it's recently become possible to write native extensions for BlackBerry 10 WebWorks. So one of the opportunities staring us two in the face is to add further NFC capabilities to it. But that'll be open source, so please feel free to join in the effort. You know, work with us collaboratively through GitHub, and do some of this stuff with us if you're interested in doing so. That'd be great.
And fix my spelling.
Your spelling?
Well, if it's open source, they can fix that. Right?
Oh, that's true, yeah.
How's it going? I was wondering, do you have a definitive list of supported tags for BlackBerry 10 and where we can purchase them?
We do have the list of supported tags. Okay. It's online. There are...
It is. If you go to, could you show the resources page again?
Yeah.
The tiny URL there actually takes you to a kind of landing page, which is a list of everything we've put together, articles, references to codes, blogs, blog entries and so on. Amongst the articles is an FAQ, which was written, most of it's about BlackBerry 7, there's some BlackBerry 10 stuff in there as well, but it does list the supported tags. It doesn't tell you where to buy them unless I've put a slightly sarcastic entry in there that Googles it for you. I can't remember, I don't know.
Yes, you have.
Have I done that?
Yes.
I thought I might have done. I apologise for that. Basically, Google, just make sure that you buy NFC Forum compliant tags. That's the key piece of advice. Tags are not all compliant with the NFC Forum standards, and those are the ones that you need. They will not work with BlackBerry smartphones if they're not compliant with the NFC Forum standards, and you wouldn't want them to, because we've got to get this interoperability thing in place, okay? So you want to go for something, you'll need to consider capacity, and obviously what you're looking to achieve is going to determine that. My default is I tend to go for type 2 tags, which have a few hundred K, tend to be useful for most purposes, but you can go right up, as Rob said earlier on, to things like 4K tags, which are actually full smart cards. You can exchange APDUs with them. So look at your requirements. Definitely target NFC Forum compliant tags, and if you ever need any thoughts or help, feel free to contact us through Twitter or something.
Yeah.
Okay.
Something worth adding to that is if you Google for NFC tags, the most common type you're going to see is MyFair Classic, and that has a proprietary encryption system on it, which we do not support. And that
Yeah,
is
so
the
don't buy
easiest one to
those.
find. So.
Yeah.
So
And I have another question. Do you have any recommendations on how to get users to turn on NFC on their phone before they launch your application and try to use it? Do you have any research on
We
how
do.
people use NFC and how that works?
one thing we do have is we do have APIs to see if the subsystem is supported and if it's enabled.
Yeah, absolutely. I mean, like, exactly the same answer I was going to give. There are APIs where you can determine whether or not NFC is on or not, but of course your application does need to be running for that to be possible. Beyond that, I'm not sure.
In terms of UI, how would you recommend that we ask users to turn on NFC or
Well, I think you can do
that
it
flow of...
Essentially, you can do it yourself. I mean, if you're talking about your UI, which means your application's running, you can determine whether or not NFC is enabled, and if it's not, you can show the settings screen. You can take them there, kind of lead them to water and make them drink, almost. Hi.
Hi. I think most of us have exactly one device which does NFC. Do you have any recommendations about how we could develop this sort of thing using maybe the simulator or other ways that you could approach the
How you
problem?
could develop peer-to-peer applications with two devices. Find a friend might be one way.
Thank you very much. No.
I'm very sorry to hear it. You're probably very productive, though. You get loads done.
Are there any like USB NFC readers you could plug in and then access them using the simulator, maybe?
You could do stuff from a PC with a reader. I've written things with Python has a really good library for kind of smart card interactions, and you can script interactions. All I've done with this is I've read the contents of tags and decoded the memory structure and stuff like that, so possibly you could do something like that. It might be better in the long run, though, I don't know, to simply get another device. Now, that might sound a glib statement, but even things like, we're talking about BlackBerry 10 today, but you've just seen the interoperability, and if you want a way to be able to test, a 9360 with BlackBerry 7.1 on it will support peer-to-peer mode, and this is a cheaper BlackBerry device aimed at kind of teenagers and things. They can afford them. I'd go there if I were you. That's probably the most pragmatic way. Or try and get that friend. I don't know. We'll be your friend. We probably live too far away from you, though.
I was just going to make a comment that
Yeah.
there's a startup here in the Bay Area called TagStand. They sell NFC tags, they sell NFC readers. Contact them on Twitter, I'm sure they would.
Interesting.
Have some of their advertising cards on too.
Very cool.
The
Sorry,
comment
are you from TagStand? Do we have people from TagStand here?
Okay, sorry. For the record, the comment was that there is a startup in this area called TagStand where you can buy NFC tags.
I'm sure if you contact them,
Yeah.
they're more than happy to come out and
I have had personal interactions with them. They're a great bunch of people. Yeah, definitely.
I'm not their employer.
Right. Yeah, I like them.
To be physical with a friend.
Very true.
Another
Let's
comment
not
that I
go
won't
there.
repeat for the record.
Okay. Yes.
I know there's a bunch of guys here who will say, oh, we could have told you the answer, but there may be others with the same question I have. There's devices you can get for the PC that will encode tags. Is it capable of, is that something you can do with a device like this?
Yeah. Yes, it's capable of writing tags and locking tags, if the tag supports it.
So the APIs are available to do that?
Yes, they are.
Okay.
And in fact, we've got codes there as well. We don't have internet access, do we? I don't know. If, again, you go to that one landing page, follow the link to GitHub for our native kind of Cascades community samples, you'll find an application in there called NFC Tool. In actual fact, I don't know if we can get the Elmo back on. I'm not going to demonstrate it. I'll just show you the UI, if I can get rid of this.
Yes,
Could we have the Elmo back on, please, briefly? Okay.
Okay.
Just to let you know that this thing exists. Oh, I don't know if we can see that, can we? Is that going to focus?
White.
Bring it a bit nearer. Yeah, it's not coming across too well. But basically, this is a menu of various NFC-oriented functions, from tag reading, writing different types of tag. Apologies for my unsteady hand here. Sending a V card, a contacts record from one device to another. You can do something called tag emulation, and not released yet, but there'll also be some stuff to do with the card emulation capabilities that I'll release in a week or so when I finished it, basically. So if you download that application, you'll see examples of how to use the native APIs for all of those kind of use cases. Yeah. Last question, I think.
I actually have two, but I'll make them real quick.
Okay.
First one is there, can you actually set the range of a tag, or are there certain tags that have different ranges?
No, not really, no. Essentially, they're all the same range.
Okay. So practically a touch.
Yeah, environmental things will impact actual range and antenna size and stuff like that. But
A great example is there is a lot of water in your hand. So if you have one of those little stickies on your hand, it doesn't work anywhere near as well as if it's on a table.
Fair enough. Okay.
Okay.
My second question was, you were talking about the unique identifiers that RIM will remember which, is that for each specific name of the tag?
Oh no, this is for the invocation target ID. It's not related to the tag, it's the invocation target.
Yeah.
Okay, fair enough. Thank you.
Okay, I think we need to close, but again, we're going to be in, where are we going to be?
The large hall.
We're going to be in the large hall in about 15 minutes' time. If anyone wants to come and chat, we're here for the rest of the event. Thank you very much for coming and listening to us.
Yep, and sign up for the one-on-one sessions as well.
What's one-on-one?
Oh, the one-on-one sessions, you can talk to one of the RIM employees.
Yeah. Okay, thank you very much.
Thank you.
Thanks.